Hello, everyone. This is Tad Radzinski. I want to welcome you to our webinar today. We're going to be talking about conquering carbon, evaluating embodied carbon in products for a sustainable future. I'm excited to have everybody on this webinar today. We have a lot of people signed up for it and logging on right now. And we're looking forward to presenting our information today about embodied carbon and how important it is as we design buildings going forward, especially in light of a lot of the challenges we're seeing, with climate change and some of the other things that are going on in the world right now. So I'm excited to uh, kick this thing off today, and I just wanted to give a few housekeeping things before I get started. What we're going to do is we have four of us presenting today. So we're going to have everybody run through their presentations. And what we're going to ask you to do is we are going to be having at least 15 or 20 minutes at the end for questions and discussion. So what I would ask is everybody to type your questions into the question pane, and then we'll take those questions at the end of all the presentations. And you can type them in at any time, and if they come up during each speaker's discussion, if you have someone specific you want the question addressed to, just let me know, and we will have that addressed right to the particular speaker going forward. If you have any technical difficulties, just type it into the chat box. We have our team here that will help you out if you're struggling with anything. And with that, we're going to get started. So I want to thank everybody for joining today. And I want to introduce our speakers. I'm Tad Radzinski. I'm the Certification Officer for GreenCircle Certified. We also have Lisa Conway, the Vice President of Sustainability for the Americas at Interface. She'll be speaking today on some of the initiatives that Interface has taken with them and some of the activities with the materials can. Then we have Kirsten Ritchie from Gensler. She's the Principal Director of Sustainable Design, and she's going to be talking about how they're really looking at embodied carbon as they dive in and work on these buildings and really trying to have a focus on that. It's really exciting, some of the work they've been doing. And then we also have Stacy Smedley, who's the Director of Sustainability for Skanska USA, and she's going to talk about how they're approaching this as a builder and some of the activities around the materials can group and the EC3 tool and whatnot that's coming out. So with that, I'm going to dive in and kick this off with a few different slides here. And what I wanted to do is really set the stage here on what is embodied carbon. Many of us, when we think about carbon, we instantly think about the energy that's used in buildings or the energy that's used in vehicles. However, when we're talking about embodied carbon is actually all the carbon that's integrated within the building products and eventually into the building as it's fully constructed. And what we're looking at is basically the carbon dioxide that's emitted during the manufacture, the transport, and the construction of the building, and all the materials that go into that. And for those of you that may not be fully versed in life cycle assessment, the first phases like materials extraction out of the earth, followed by manufacturing of those materials into products that we will use in the buildings, and the transportation in between, and then the transport to the building, the installation into the building. All of those have a carbon footprint because it takes a lot of energy to produce products. It takes a lot of energy to transport them. Even on the installation phase, there's some energy required at times for that. And then embodied carbon also would include any kind of, basically embodied energy, which would be things like if you need a fossil fuel feedstock to make a product, that would be captured in there as well. So I'm just wanted to set the stage on that. And what we're going to have is some of the other speakers are going to go into more detail about how the two are related and some of the the values of this. But when we think about embodied carbon in buildings, we can look at it from the perspective of one building product at a time, or we could actually really take a hard look at a whole building life cycle assessment. And when we do a whole building life cycle assessment, as you can see on the right here, we start out with the extraction and processing of raw materials, the manufacturing, distribution, and then the installation. So this phase would be all the embodied carbon activities, whereas the use phase, maintenance, that kind of thing are actually part of carbon emissions that occur from building use. We actually have a sister company called Sustainable Solutions Corporation, and they've done some whole building LCA work. And this is just a example of something they have done where they looked at a building. The scope was one building with basically a estimated lifetime of 60 years service life, and they looked at a cradle to grave analysis, and they basically looked at various materials when they built the LCA model around this, where they were looking at the concrete, the masonry, a lot of the finishes, openings. These are the different divisions that they focused on when they built the actual model. And when the results came out, it was really interesting to see where were the big impacts by uh, CSI division and then different product specific areas. And you can see here when you really look at this, obviously concrete has a very large footprint when we're talking about global warming potential or embodied carbon in products. And then we start to see some of these other things like finishes. You can see here this light blue would be finishes. This is a big chunk of the pie. So this would be things like, the flooring, the ceiling panels, the gypsum wallboard, the different things going inside the building. Whereas the envelope would be covered by like some of the concrete, the metals, things like that, the actual structural steel that goes into the buildings. And I know that Kirsten and Stacy will talk more about that on how they're looking at some of these things. And then, we try to break it down even more, getting a feeling for where did some of these things come out. And you can see here, flooring, the floors actually had a big area of global warming potential or embodied carbon that came out of the whole building LCA. And the nice thing about doing these whole building LCAs is it really allows you as a designer or an architect to kind of zoom in on, what are the most important things that you should be focusing on if you're really trying to design a building that has lower embodied carbon. So this is just a nice tool that helps us to zero in on those areas to focus on, and that is something that we'll hear more about today in our presentation. The other thing I want to talk about is it's really important for building product manufacturers to really think about creating more sustainable products, especially for those that are in those divisions I just showed. And this is an example. On the left here is actually a spider graph. At GreenCircle Certified, we had a plan early on when we started this company to really start to think about reducing embodied carbon, reducing life cycle impacts of products. And we created a certification called Life Cycle Assessment Optimized, probably back in 2011. And we were definitely way ahead of our time because, by the time LEED version 4 asked all these manufacturers to start creating EPDs and really diving in hard on these LCAs and understanding, the environmental impacts of their products, there wasn't a lot of that out there. But we did actually certify a product for CertainTeed Saint-Gobain, and this is the spider graph from the first certification we ever did that for them on LCA Optimized, where you can see here the blue would be their baseline product, and the green shows that they actually reduced their embodied carbon of the product by making changes to the recipe, integrating recycled materials, improving the manufacturing process. So they were able to really improve the embodied carbon and reduce it by well over 30%, as well as these other impact category areas. And now I know that Saint-Gobain has taken this, and they've actually created their own program called SCORE, where they're really looking at many of their building products and trying to decide how do we make them more sustainable. So they actually have a formal process for all their new product development teams. Another company that's we've done some work with is Assa Abloy. They've actually adopted this globally. Our sister company worked with them to develop a customized sustainable product innovation program. And you can see here, this is an example of how they're looking at their products and looking at not only reducing embodied carbon, but increasing recycled content, going circular, making the products more recyclable and repairable and reusable. So there's a lot of neat things going on by these different companies, and this is something that Assa Abloy has promoted in their, is talking about in most of their sustainability reports, and they're marching forward with this. These things are not only good for us as people that are trying to look at products or design buildings, but the manufacturers, when they do this, it provides cost savings for them. In this particular example, Assa Abloy was able to reduce the cost of creating one of their products, so it cost them less to make it, reduce packaging, things like that, but also resulted in a lower carbon footprint. And I will say that many of the building product companies that we've been working with, those are also looking at operational or in-use phase carbon, and they've been really focused on improving energy efficiency of products. We've certified a number of products for certified energy savings. This is one way that we're measuring the improvements in products. This is our certified environmental facts label. For those of you who haven't seen, this is our multi-attribute label, and we cover multiple things on this. We focus on product-specific attributes of products. We look at material ingredient reporting because that's an important area. We also look at the manufacturing specific. And then the nice thing about a label like this is it allows us to third-party verify claims by manufacturers that shows how they've reduced the embodied carbon or in a product, or how they've integrated recycled content or gone closed loop. And we've also done things where we verified material ingredient reports. And everything you see here that's got text around it, everything here will contribute to LEED credits. So if any of you are looking to get LEED certified buildings, this label covers many of the attributes that are really important. And I do really want to emphasize that everything on this is third-party verified, and it's done to specific standards, whereas there are other labels out there that look like this, but I can tell you they're not third-party verified. They're just created by the manufacturer typically. So if you really want that information, it's important to make sure you're selecting those products that are third-party certified. These are some examples of companies that have earned this. Here's one for Interface. I'm not going to spend a lot of time on this because Lisa's going to talk about it. But you can see here, we talk about the carbon footprint reduction, and this one's really impressive, 32% reduction compared to a baseline year. This is the kind of products you want to be thinking about if you're thinking about reducing embodied carbon in a building. Here's another one that we've done for Tarkett, where they've actually had a 4% reduction in the carbon emissions for their manufacturing, and they've basically disclosed here that they do have a carbon footprint for the product, but they haven't really shown much optimization in the product itself. So multiple ways we're looking at this. If we're third-party verifying these manufacturing specific, which then usually will contribute to reducing the embodied carbon. Same thing over here with Interface with closed loop. They integrate a lot of recycled carpet back into their product, which also contributes to this carbon footprint reduction. And this is another example of an LCA optimized product that we've done where we actually show all the attributes that are certified. We are in process of updating these labels to actually include the other life cycle attributes in the label, and we're going to have a section that's going to be specifically for optimized products. So that's everything I wanted to cover to set the stage here, and I'm going to turn it over to Lisa now, who's going to talk about some of the activities she's doing with the materials can.
Awesome. Thank you, Tad. And thank you all for joining. We're really excited to be talking about embodied carbon for a whole hour. It's our favorite topic. So if we can just start my deck, we can go through some of those. And you can go, yep. Oh, yep, perfect. Right on this slide, I just wanted to explain a little bit of how Materials Can came into being. Materials Can is the Materials Carbon Action Network, as you see there. And the reason for its existence is really because we've been, as an industry, reporting on carbon footprint of products for a pretty long time. I mean, you can always have more EPDs, certainly. But even in the 10 years that they've been in existence, we're still really only at a point where projects are collecting EPDs in order to get a credit for LEED, as an example, and not being rewarded for actually reading them and acting on the content that's in there. So we worked with Gensler actually in the very beginning, who had as one of their criteria from their Impact by Design report to collect better performance metrics on buildings. And one of the examples given was to measure the embodied energy of the materials that they specify. And it was through that collaboration that we decided to start an open collaborative. So this is not only meant for the partners that you see on the screen. We certainly hope to expand it. But we wanted to capture more of the market, and especially around interiors. Obviously, all of these, maybe with exception of Interface, create some materials for commercial buildings as well. But we wanted to focus on interiors because if any of you have nerded out on embodied carbon, you know that a lot of the conversation is around concrete and steel. And ideally, we're reusing buildings that already exist. And once we get inside a building, that doesn't mean that we're off the hook for having to think about it, because there's so much churn of interiors, especially in tech, hospitality, retail, as you can imagine. So we started with these 6 partners, Skanska representing a GC, Certainteed for insulation, USG for wallboard, and then Armstrong for ceilings. And since then, if you can go to the next slide, we've actually added 2 more partners on the manufacturer side. So Superior Essex for communications cable and Kingspan insulated panels. Next. So the mission of the group is to drive awareness like we're doing today and take action, which you'll hear about in all 3 of our presentations, on the highest impact aspect of energy consumption in the building industry. And I'll give a little bit of context to that in a minute. Next. I want to frame this whole conversation in the framework of impacts of climate change's impact on human health. And that is really because some of you may have come to this call because you're already sustainability freaks like us, maybe because you were told that you should do something around sustainability, and you know, there's obviously a million reasons why you could be interested in this topic. But I think that even for those of us who are super deep into sustainability, sometimes it's really helpful to contextualize this conversation around something that everyone can really get on board with. And that is the impact that climate change has on human health. And this is important because some of us care about, you know, carbon emissions and polar bears and melting glaciers, and some don't. Some really don't realize the connection that climate change has to our everyday lives. So I just want to explain this slide for a minute. The center wheel that you see turning there represents the rising sea levels, increasing CO2 levels, rising temperatures, all of the things that we would associate with climate change. What we don't necessarily associate with climate change, but what all of that leads to, is the secondary wheel. So imagine you can't have a Hurricane Harvey without it having an effect on water quality. You can't have the wildfires that actually just displaced my vacation this past weekend, which I'm not worried about. I'm just worried about the people whose homes are burning down. But you can't have all of that stuff burn without it affecting air pollution. And then things like changes in vector ecology, not going to make the nightly news. But this is all about insects that carry disease, and how when we have longer seasons and insects have more of a chance to breed, there is more of a chance of people getting infected. Then if we look at the outer wheel, this is what we actually experience, either ourselves, our communities, our families, etc. Things like asthma. Climate change doesn't cause asthma, but it exacerbates asthma. So more symptoms can be felt. Lyme disease is one that's personal to me. My mom has Lyme disease, and she can watch our kids for a couple hours at night. They can sleep over, and then a couple hours in the morning, and then they have to leave. And it takes her a couple days to really bounce back from that. Things like respiratory allergies, who doesn't have those? And then even things like forced migration and civil conflict, where if I can't grow crops on my land anymore and I have to move my family, I may or may not have the means to do so. That obviously leads to significant mental health impacts. So just before I go forward, I just wanted to make sure that we were all clear on how this is part of the health conversation, especially when it comes to interior products. We've kind of been squarely focused on toxicity, and embodied carbon is really part of that health portfolio, or health, the health considerations. Next. So this is a slide that hopefully people have seen from Architecture 2030. This takes a slice of where carbon emissions are coming from in the next 30 years. So a typical building life cycle is going to be more like, as Tad stated earlier, maybe 60 years. Often we hear 80 to 100 years. Over 80 to 100 years, the largest carbon impact comes from operating the building, for sure. That's why we have LEED. That's why LEED gets written into code, etc. But what we really haven't been focused on at all is the embodied carbon. And if we're talking about reversing global warming, which is the goal of everyone, hopefully on this call, then we really need to understand where are the emissions coming from right now, a smaller slice of the pie. And for global new construction, that is actually half from operational carbon, which we know how to reduce and we're well versed in its reduction, and then half from embodied carbon, which is the carbon that makes up the materials that make up the buildings and the construction. So what we're focusing on today is at 49%. Next. And then this is some older research from Architecture 2030. This is actually a slightly longer time frame, 35 years instead of 30. But the point here is to look at numbers based in the US. The last ones were global. So we actually get a significant carbon drag on operational when we look at the numbers from a global perspective. We've done a much better job on operational energy in the US. So in the next 35 years, the great majority of the carbon footprint is going to come from building materials themselves. The number one highest carbon footprint is going to be concrete. Number two is steel. But once we get inside of a building, it can actually be carpet. So let's take a look at the next slide. Oh, I'll show you that one next. This is the goals of the group. So, and I don't need to go through these. High level, drive awareness, share methodology, take action, and expand the partnership. What I'd like you to hone in on is the second and third bullet point of this, because this is where everyone can participate. The point of materials is again to raise awareness and provide education, but that doesn't mean that others can't participate, and we'd love to share methodologies and case studies that you may create for how to prioritize carbon in specifications, and then create case studies on low carbon, which is a reduction from baseline, carbon neutral, which probably means purchasing offsets to get to zero, and then carbon sequestering interiors, which is what gets me out of bed in the morning. This idea of creating interiors that can actually be part of the solution to reversing global warming instead of just measuring how much less of the problem it is. Because I don't know about you, but 10% year over year doesn't really get me all that excited. But the idea that we can start measuring positive is really, really exciting to me. Next. So here's the how. It's been very painful. Kirsten can probably share some of her pain next, and then we'll give you kind of a lot more hope for this being easier at the end. So as I said, this information has lived in these 17, 18-page EPDs, but no one has been reading them. Next. This is, if we could take by product category and actually pull the information out of the EPDs and compare them with other products, that's ideally what we'd like to get to. And we're gonna share a tool with you at the end that Stacy will share that'll help you do this at a larger scale. But this is an example. If we're looking at healthy materials and a product that has the highest carbon footprint available in the industry is red list free, then that's a significant health trade-off. So this can help, this information can help see more of the comprehensive view of a health profile of a product. Next. So this information currently can be found in two places. Well, one, you can read EPDs, but if you want it to be easier, you can find it on the GreenCircle Certified Environmental Fact Label, which Interface has had out for 5 years. So our carbon footprint reduction from the first time that we did the label is a reduction of 32%, which is very significant. And then the Declare label has also, through the work of Materials Can, had this added so that we can start to see some of the more comprehensive view of a health profile. So when you see that indicator, the green indicator, on the right of the Declare label, that means that it's under the 20% threshold for the product category as determined by EC3. Next. And Kirsten's going to go through this one. So this is a little preview, but this is a way to visualize embodied carbon reduction in a project. So she'll get into the details, but just wanted to show you that there's a nice visual way to represent a reduction and measurable reduction in a project. And with that, we'll move to Kirsten.
Okay, thanks, Lisa. Good morning, all, or good afternoon, depending upon what part of the country you're in. I'm Kirsten Ritchie. I'm a principal here at Gensler, and I've actually been involved in kind of the green building world for my entire career of various parts. I actually started on the waste side, so I'm really excited to kind of be part of the movement that's helping to change and shift up how we use and assess materials. So next slide, please. So what I'm talking to you this morning about for a few minutes is really the idea of how we designed with embodied carbon in mind. And this is really focused on the built environment. And just you have a little note, I don't know how many of you are aware, but just a couple of weeks ago, right at the time that we had the UN Global Climate Summit, Gensler announced our GC3, which is the Gensler Cities Climate Challenge, and we've basically made a statement that we want to see greenhouse gases gone out of the built environment. We think it's actually kind of the lowest hanging fruit, what needs to be done, and really can shift up kind of the global climate situation. And when we're talking about getting it out of the built environment, we're talking about on the operating side as well as the stuff that's in the materials. So how are we doing that? Next slide. So we been very fortunate over the years to do a lot of work with San Francisco Airport. I'm presuming a few of you have flown through. And we launched, this is about 3.5 years ago, launched the renovation of Terminal 1, which houses Delta, Southwest. And it's one of the oldest of the terminals at the airport. And SFO at that time basically said, okay, what we want you to do is you need to redesign this. It's a 770,000 square foot space to handle about a 70% increase in passengers, so from 10 million to 17 million people, improve employee and passenger satisfaction and delight, increase revenues from retail, food, and beverage operations, and lower energy use and reduce the carbon footprint as far as possible while being financially possible. This was really the first time that the idea of the carbon footprint, more than just the energy footprint, was something that SFO wanted us to look at. And I think many of you might have been following it. SFO for years has been really kind of a leader on environmental and sustainability as it relates to airport operations. Oh, and yeah, one little detail, keep this terminal operating while you're doing all this. Yes, a nice little challenge there. So we said, yeah, we're in it. We're going to take it on. And so next slide, please. So in addition to doing all the kind of energy stuff and reducing the carbon from energy, we actually, and this was the first project that we did this, we did whole building LCA on the structure itself. And we did first a baseline, taking the design and saying we're using, average, industry average, carbon footprints for materials. What does it look like on our project? And as we, typical design and structure, and you see that's the red. And so you see, from a baseline perspective, we were looking at about 52,000 metric tons of CO2 equivalent of emissions and carbon emissions. That stuff going into the air right now from our baseline design, and clearly it was concrete and steel. And so we worked very closely with our structural partners, MKA, on this, and they actually have been doing a lot of stuff over the years to say, okay, how can we reduce the footprint of steel and concrete? On the steel side, one of the major moves we did is we said we don't want to do anything that's going to force us to use Asian steel, and I'll show you why of that in a minute, because we know it has a much higher footprint. So that basically meant, hey, avoid jumbo members, avoid unique stuff that only can be fabricated there. We're looking for those things that can be put together from pieces that can come out of North America. So that made a significant, by doing that, we significantly reduced the carbon footprint. And then we were, kind of implementing what are those incentives or what are the things that we can do to actually get the best of the North American steel. And that through what we did there, we significantly cut the footprint associated with wide flange and plate steel by about 50%, which is huge. On the concrete side, this was really about matching first of all, focusing on performance criteria, not prescriptive criteria. We're not going to tell you how much cement has to go into the mix. We're telling you, how hard we need it, how fast we need it hard, what's its actual function, and then working with the concrete suppliers to optimize the mix designs to reduce the cementitious percentage. And for there, we were able to reduce the footprint on concrete about 15%. Other materials as well, not as much as clearly on steel and concrete. This is a big, ginormous rebuild of a terminal. And so the foundations and the structure and the superstructure really dominate on this project. But because of what we're able to do, we basically, at this point in time, believe that we're going to be able to reduce the carbon footprint of the core materials close to 20%. And basically bringing the footprint of the building down to about 120 pounds of carbon per square foot, which we think is pretty awesome. And what we did, oh, by the way, this was done using Tally, which is a plugin to Revit. So our model is all in Revit. And then we worked with Urban Fabric, which is a sustainability consultant, and they've developed a strong life cycle assessment capacity of projects, and then worked side by side with them on implementing this. Next. So this is something, when you talk about, this is actually the result sets of a current project that we're doing, and but it does give you the idea of when we talk about, like, for example, structural steel, just the huge variety, range of footprints in products that are available in the marketplace right now. It really is kind of it is eye-opening, we think, and somewhat scary, but also it gives us hope that we can change things. So the first line there is the ICE, and that is an industry average database. It's a global average. It stands for the Inventory of Carbon and Energy, publicly available. Anybody can access it. And ICE currently says that the average global warming potential of structural steel around the world is, somewhere around 1,500 kilograms of CO2 per metric ton. Can you go back, please? Thank you. And so that's what that's showing. And then you see Tally, which is, again, I mentioned the plugin, and they use more North American, typically North American, but also global average EPD information. And they're saying, we really think it's actually, for North America, it's really just a little bit below 1,000. And then you have the Association of Independent Steel that actually has done an industry-wide average. So that is what, particularly if you're using, if you're going for LEED, that's the kind of the baseline, that's the norm now, and you're showing, it's somewhere around 1,200 kilograms of CO2 per metric ton. If we then drill down and you look at Nucor, which is a dominantly North American company, they are showing their current steel production is 24% less than that baseline, which is amazing. Europe is a little bit higher. Arxela in Europe is even a little bit higher. ThinkStep, which is another sustainability, it does a lot of work on environmental product declarations for companies. They're showing about 16% reduction. But here's what's really interesting. If you look at the impact, the global warming footprint of product coming out of China, this is kind of like in your face why it's a problem. And so, really saying, hey, what are we doing on our projects to make sure that we can source steel from lower carbon footprint producers? Okay, next. Lisa talked about kind of the integration of climate and health, and a lot of people don't really understand the impacts of carbon as it relates to health. We also, as part of our project for SFO, we're required to do a sustainable return on investment, where we looked at a number of different strategies that we're implementing, and determining which ones really, as we add in societal and environmental benefits that are quantified financially, where are we opening the amount of basically
Sounds like we've lost Kirsten. Can
take us to really find them and specify them. Hello?
Kirsten, we lost you for a minute there,
Oh,
so you might need to repeat some of what you said, please.
just here on the SRI? I apologize for that.
Yes.
Yeah, so here in SOR, this is a sustainable return on investment. We actually used a tool from Impact Infrastructure called AutoCase. And what it does is it basically takes kind of it along with your traditional financial variables like your CapEx, your O&M costs, replacement costs, it adds in the financial costs of social and environmental aspects, such as air pollution that results from the activity, or carbon emissions, or employee productivity. And in our case, we looked at a number of different strategies, but we were really amazed by the benefit that's derived by specifying lower carbon materials, because it all comes back to reduced illness, reduced absenteeism, reduced because of reduced asthma rates. There's all those things that Lisa showed in that chart before that we're actually able to now start quantifying or financially quantifying that, and we can calculate what the benefit is associated with that reduction. So that close to 19-20% reduction of carbon footprint that we had for our project basically has resulted in a positive health benefit on the order of close to $13 million at a cost of about $100,000 to do all the kind of design work up front, and really there's no additional cost on the material side. So we're netting out at a benefit cost ratio of close to 130, and as I mentioned, anything more than 1 is great. So this is like off the charts, and even kind of more reinforcing why it's so important and so smart for us to really start paying attention to the carbon footprint of the materials we specify. Next. So this is another looking again kind of on the steel side, but this is rebar, and chances are all of you, if you're doing, as designers and contractors, you touch rebar in a project. And so again, the same thing where we're having on the international basis, you see that the global average global warming potential is almost 2,000 kilograms per metric ton for rebar. And Tally in this particular instance was also reporting out its average was based on global, equally up there. Bringing it back down to North America, you see the baseline is about half of that. And it's really a lot of it associated with the fact that we have a lot of electric arc furnace that's powered by more renewable energy, whether it's hydropower or it's lower carbon energy. It might be natural gas than coal that's used predominantly in furnaces outside of the United States, particularly in China. And then again, you see going down by specific vendors or manufacturers. Nucor again, I mean, they're doing a phenomenal job of bringing down the footprint of their rebar products, close to 50% of the U.S. North American average. And you see ranges here, so it starts to see, and you see some that are kind of way over there. With Salad at 1,400. So it's on one hand, for manufacturers, it's kind of scary that this information is getting out. From us as specifiers of products, it's great that this information is getting out. We fully expect and hope that with time, everybody's going to be much lower than they are now. I mean, this kind of the market incenting one another, but it pays attention to really kind of get at this kind of information and learn. And so all of you can immediately go and say, okay, who are usual go-to rebar suppliers and what does their footprints look like? Next. So when we put it all together for the Terminal 1 project, and this is integrating both the operating energy as well as the embodied energy, we estimated that over the 50-year operating life of the project, that the carbon footprint currently is about 593 pounds of CO2 equivalents per square foot. As we designed it from both operating energy efficiencies as well as sourcing clean renewable energy, as well as lowering the footprint of all the materials, we brought it down to 124. So overall, we are delivering to the airport a project that has, over its 50-year life, a 79% reduction in its carbon footprint. We're not getting to zero, but we're getting pretty darn close. And we're very excited about it, and the airport is as well. Next. And as Lisa alluded to, but these projects don't have to be big scale. This is another project where we did, it's very small, it's a 10,000 square foot a tenant improvement in a high-rise here in downtown San Francisco. And again, we kind of did the same process. This we actually just did using Excel. There's a lot fewer materials. It was much easier to manage. And we did analysis, and we found that, as we just kind of generic design where you're not really paying attention to it, what would be the footprint? And we found that, the footprint was about 11 pounds of CO2 emissions per square foot, and the large chunk of it coming from carpet, and which, in part because it's all polymer, and if you don't use recycled content, it's a big burden in renovation. Steel makes another big difference, glass, and in terms of office and conference room glass fronts. Wallboard is another big one, and then insulation and even paint. And I was like, paint's water. Well, it's not. Paint's polymer. It's plastic. It has a carbon footprint. And so those are the kinds of learnings, as well as sealing. By being very specific about the products we specified and specifying really low carbon, for example, carpet, we went with the interface plant-based, the interface glassback RE, really reduced the carpet footprint. We did a little bit on steel, but we didn't do so well on reducing that footprint. We just weren't aware that much. And so that's something that really became eye-opening for us. In terms of glass, we found out that laminated actually has a lower carbon footprint than tempered, and that was something that was kind of surprising. Wallboard, there are big differences in wallboard, and I'll show you on the next slide. And even things like sealing. When we went with the Armstrong plant-based Optima PB and reduce the footprint of the ceiling. So overall, we were able to reduce by smart product selection with no price differential. It reduced the footprint of that project by 42%, down to just under 6 pounds of CO2 equivalents per square foot, which we think is pretty awesome. Next. And I mentioned, so wallboard. Again, wallboard is really interesting. You start to see, wallboard, but there are big differences. And again, you have, kind of what the baseline is, showing it a little over 300 kilograms of CO2. Now, this is per 1,000 square feet. It's the quantity is a little bit different, and so you always have to be aware of that. But you can see, this is like using, looking at USG sheet rock. They're Eco Rock Type X. They've become the baseline, which is great, and others are on the other side of that. So again, these are things to be looking at. We do want to make sure that when we're comparing equal performance and function. That's really important, because it's not really, if you don't, you just need to be careful of that. But again, looking through the different sorts of products, and you can make differences, and these are all competitively priced. And so again, get lower carbon. At fair market value. Next slide, please. But the really important message is, if you don't spec it, you're not going to get it. Speccing it either as your basis of design product, and providing very clear direction on, if somebody's going to propose an alternative, what the criteria are that you are going to accept that alternative on. But also just even the starting to say, we are going to require that you submit an environmental project declaration. So one, that you even have it, and that you're doing it, and that we are taking a look at it, because we are going to quantify our carbon footprint. Really important. And then you can start to do things to influence the impact of those requesting the EPDs. In this case, with the T1 project, we weren't in the position yet to put down a hardcore global warming potential number, but we were able to say, hey, we think what we want the contractor to be able to consider the global warming potential in the purchase decision. So because it is a public bid, and typically you're looking at low cost, this actually gives the contractor some feasibility to say, hey, we can take that into account when we're finally selecting the product. So, but again, the important thing is, if you don't spec it, you're not going to get it. And please get this information into your specs. And that's it for me.
All right, thanks. I'm going to try to speed through this so we have a couple minutes for questions at the end, but not go so fast that you don't know what I'm talking about. So, hi, I'm Stacy Smedley, Sustainability Director for Skanska, and I'm going to walk you through what Skanska's been working on when it comes to supply chain accountability specifically. So if you go to the next slide. Really reducing the carbon footprint of every building that we develop and construct. Next slide. So we always start with the impact first, and I think this is important for all of us to have in our brains that over the next 35 years, 2 trillion square feet of construction is happening worldwide. If you go to the next slide, that's the equivalent of an entire New York City every 35 days for the next 35 years. So from Skanska's perspective, being a global contractor, if we're not thinking about the impacts of that much construction and doing whatever we can to reduce the environmental impacts, we're not being responsible. So what we've been focusing on for the past 5 years or so is really understanding the carbon impacts of the whole building life cycle. And again, this is that embodied versus operational breakdown. And what Skanska does is all this embodied carbon stuff when it comes to procuring materials that are being sourced and extracted and manufactured and brought to our site for installation. Next slide. You saw this on Lisa's slide. This is just really, again, that time value of carbon, getting the 50-50 in our brains, that the embodied carbon stuff happens at the beginning and it's there once you've done it, and it doesn't reduce over time. You've expended it at the time of construction, so we need to reduce it at the time of specification and procurement. Next slide. So the first thing that Skanska did was try to figure out how we could start to look at quantifying this and giving a potential embodied carbon impact to clients and ourselves. So we funded a study at the University of Washington Carbon Leadership Forum. The link is down there on the left, where there's a source of carbon footprinting data from over 1,000 buildings sorted by building type, where you can actually look at kind of a high and low embodied carbon number per square foot or square meter. And what this does, if you go to the next slide, is allow anyone, including us, to take a square footage of a project with the location, an energy grid, and EUI, and start to really understand what the potential impacts and breakdowns are of embodied carbon versus operational. So in Seattle, for a mid-rise office building, business as usual when it comes to embodied carbon procurement of just typical materials without really thinking about it as a driving factor. It looks something like this, where over a 50-year life cycle, 84% of the emissions are in the embodied carbon bucket. So we started showing this to all of our clients, and they started asking us, what are you going to do to reduce this if you're showing us that this is where the problem lies? If you go to the next slide, what this led to was us demonstrating this impact for the Microsoft campus project here in Redmond, Washington, with 18 buildings, 2 million square feet of construction. And of course, the impact was large on both sides, but Microsoft has done a really good job on the operational side, but hadn't really even understood the embodied carbon side until we showed them that slide for their campus. So they also asked us what we're doing about it. This was about 2 years ago. And if you go to the next slide, what this led us to is actually looking at how contractors play into this whole building lifecycle assessment and how we can start driving specs of procurement and supply chain reductions after those kind of first initial assessments are done. So this is a slide provided by Tally, looking at how a workflow of LCA happens at the beginning of a project that then goes into making systems and large-scale materials choices like steel versus timber, or envelopes to system A versus B. But once you've done that, really digging into those specs and doing what Kirsten was showing, which is looking at the various products, was something that there was no tool for. We all have to go do it, and I don't think Kirsten wants every single person on this webinar to call her to ask her for her data or have her help. So the idea was, how do we kind of fill that gap with a tool that really allows anyone in our industry to assess products based on embodied carbon per material category. And if we can do both of those things, the whole building LCA plus the embodied carbon supply chain procurement, then we're really getting to embodied carbon reductions that are realized. So next slide. Once we had talked to Microsoft about this, Skanska funded an innovation grant through our internal program to develop a proof of concept, with Microsoft jumping on to help fund. And what that did was help us, if you click, set up a list of criteria for a tool that would be embodied carbon and supply chain specific. And really what we wanted the tool to do was be available to everyone, be easy to use, so it takes 1 or 2 clicks to get to those material level comparisons, be free to use so that there's no barrier to use by anyone in the industry, have open and transparent data so you can see where it's coming from, have an open API so the tool can then be used in anyone else's tools when it comes to the code and the EPD database that we're developing, and then be focused wholly on supply chain accountability, so we're driving each manufacturer to disclose and reduce. And that's led to the Embodied Carbon and Construction Calculator, or EC3 as it's been called in most cases these days. Once we got to the proof of concept, we turned the tool over to the Carbon Leadership Forum at University of Washington for management to ensure that we could get industry buy-in and have it not just be a Skanska or Microsoft-led project. If you go to the next slide, what this has led to is an industry-supported tool. All the folks that you see on the screen are supporting either through the methodology and material working groups for the data side, piloting the tool as we develop it to make sure it works for different components of our industry, or sponsoring the tool because they believe that it has a place in embodied carbon reduction. So this is just a slide that kind of shows the breadth of support right now. The next slide is kind of the current ecosystem of other partnerships and quick stats. So we've got data partners that include Climate Earth when it comes to digitizing EPDs into the system. We're partnered with Sustainable Minds and Mindful Materials to export embodied carbon data into those platforms. We're working on an export of tallies, LCAs, and bill of materials into EC3 for supply chain accountability and choices. There's a BIM export from Autodesk, and we're working with the large program operators to optimize their EPDs to be digitally transferred as well. We're also working with certification entities and public policymakers. So we're testing a buy clean component to the tool that allows people to sort by buy clean policies like the one in California and get only products that meet those criteria. We're testing limits for concrete for City of Seattle and King County. And we're also working on a pilot credit for LEED version 4.1 that allows supply chain reductions to earn points, as well as being a way to comply with ILFI certifications and getting the embodied carbon on declare labels. So there's lots going on. We currently have over 100 active users piloting the tool. We have 700 folks signed up for access when the tool launches on November 19th at Greenbuild. And we're currently including the list of materials you see here, which are the main structural components and the core and shell in the first round of interior components like gypsum wallboard, carpet, and ceiling tiles. If you go to the next slide, it's going to show you kind of the math behind the tool, and it's pretty simple actually. We need material quantities and we need embodied carbon numbers from EPDs to get to a building embodied carbon estimate. If you go to the next slide, we're getting those quantities, like I mentioned, from a few sources. You can actually just input an estimate from a contractor that has quantities of all these things. You can import your Autodesk model. You can also import your tally bill of materials from an LCA. On the EPD side, if you go to the next slide, we're getting, of course, getting the global warming potential numbers from EPDs, and this is just my simple comparison of what an EPD is compared to a nutrition label. So I call it a environmental impact nutrition label for a product, where it's got a declared unit, just like a serving size on a food item, as well as the kilograms of CO2 per unit, which is similar to a carbohydrate on a nutrition label. The tool actually currently has about 17,400 EPDs. So if you go to the next slide, this is what you'd see at the landing page of EC3. It'll show you how many EPDs we have per category right now. You can see that concrete is up over 17,000. It's the crux of the EPDs because they are per mix EPDs for suppliers nationwide. The next slide is going to show you how this rolls up into an actual building. So if you set up a project and you have quantities and do your searches and sorts of materials, you're going to get to this level of detail where you can actually look at the various material categories, and that white area that you're seeing in each bar for each material is the low-hanging fruit. That's the emissions reduction available right now based on supply chain information in the tool. So what this allows you to do is look at the rebar and understand that variance of emissions is due to the fact that if you choose locally produced rebar, you're going to get to that white level of reduction. Similar for structural steel or concrete ready mixes. If you're doing your search for your local market, it will tell you what that reduction is for a possible target or goal. And then it rolls it all the way up to the right to an actual project reduction target. And again, we call this a low-hanging fruit. There's no reason this project couldn't go reduce their embodied carbon by at least 25% right now based on available things in the supply chain, available products in the supply chain. If you go to the next slide, the way that you get to this level of data per material is by being able to search and sort by the performance characteristics, compliance and certifications, location of the project, and click search to get a return of all the EPDs that meet your criteria. What you're seeing on the right is the conservative and achievable targets that we're setting, and this is basically showing you that the highest EPD in that search over in that little green whisker plot is 695. The lowest is 79.8. And that conservative number is set at the 80th percentile. So if you set that as a baseline, you're pretty likely to get it, only 20% or higher. If you set a target down at that achievable number, you're pretty likely to get it. There's still 20% below that. This is all explained in the tool. I'm trying to go fast, so we have a couple minutes for questions. The next slide is going to show how that looks, the material comparison looks in EC3. So just like Kirsten was showing you, this is looking at concretes for a specific region where it's going to return back the suppliers of those concretes in your region and show how they compare with their EPD collections. So you can see supplier A is in that kind of 261 to 353 range for all their mixes of 5,000 PSI strength. Supplier B is doing better, and I know that's because they've had EPDs in place longer and they're optimizing their concrete mixes. Supplier C is just getting on board and only has one EPD so far. Be able to click 2 or 3 buttons and get to this level of analysis for all the materials in the tool. If you go to the next slide, it's just an example of what this looks like for an interiors project where you're looking at just interior scopes like gypsum board, topping slabs, carpet. You again see that 50% reduction possible for carpet based on the supply chain. If you go to the next slide, you'll be able to understand that, why that's happening. This is showing you all the suppliers. Interface is supplier A in this slide. But what you're seeing here is just the range of the embodied carbon of carpet tile products globally. These are all the different manufacturers. So you can start to right size and directionally make choices based on knowing where the suppliers fall against each other and setting some baselines and targets based on the data. And the next slide is just kind of the cartoon version of what this means. If we start to do this per material category, manufacturers know they are being compared. We are using third-party verified data. They will need to disclose and then work to reduce their emissions. And if we start asking for the lower embodied carbon target or product, again, that low embodied carbon target starts to go down the more the market demands it. And we're finding right now on projects that are piloting that a 30% plus reduction is possible just by having the data, using the tool and asking. I talked really fast, but it gave us, I think, 2 minutes left for questions.
Yeah, that's great. Thank you very much, Stacy. This is Tad Radzinski signing back on here. We do have a lot of questions that have come in, and we only have a few minutes here. So what we'll do is we'll answer 1 or 2 of these, and then we will actually, when we send the recording out and the other information for this presentation, a copy of the slides, will actually answer some of these questions as well. So we'll distribute these to all the panelists, and we'll get responses, and we'll get these all back to you. One of the questions I can see here is, when creating design plans for a building, are you considering adding in materials that will help to continue to sequester carbon, is a question. And I don't know, that might be for Stacy or Kirsten.
Yeah, well, I think there's at least, let me step in on that, 2 areas. One, we are looking a lot more at CLT, cross-laminated timber, and using that for bigger structures, and so clearly wood-based projects will be sequestering. The other thing too is that we really have found the importance of increasing landscape materials on the grounds and providing direct connection from kind of the surface into the ground, because our soils actually can be great carbon sinks, can be great sequesterers, but you got to get the carbon to them. And so it's breaking up pavement, getting roots down, getting stuff down there. So that's just an area that's emerging. There's the whole MBS movement, that's Nature Building Solutions, I think it is, that's coming out. But we know that we really need to get more landscape into the projects. But on the material itself, the bio-based stuff, we are looking at things and their potential, some options on wall structures, maybe on flooring materials, but the big move would really be more the CLT and high-rise kind of timber construction.
Okay, that's great. There was another question that says, what is typically the best method for evaluating the carbon footprint? And the options are Tally, Athena, or programs like EC3.
I would just, I think I would add to that, going back to my slide, it depends on what phase and what decisions you're trying to make. I think early on, the whole building LCA tools that give you kind of all stages of use impacts and also uses more average data are good for looking at different structural systems or an envelope system with this insulation and this glazing type versus another one. So you're making directional choices on systems. When you're really trying to actually specify and procure the low carbon product that meets what you've decided in those early stages. So what insulation should I use that meets my criteria? What concrete supplier am I going to procure from? Where's my steel coming from, et cetera? That's really where EC3 comes in to help with that kind of spec and procurement process.
Yeah, and I'd like to add, I would say focus. Our designers, architects typically are focused on a particular site. They may be more interested in the curtain wall, or they may be doing interior finishes, and say, okay, let's just even start with what's the footprint of our go-to supply chain. because you have your favorite, glasses, you have your favorite carpets, you have your favorite ceiling materials, and say, what does that look like? Let's just go and find and get the EPDs of those, and find out what the carbon footprint is, or ask them to give it to you and show you where it is, so you can inform yourself and educate yourself, and then you can expand from there.
I would say please use EC3 for that, for the materials that we're including, because the reason it exists is so that we don't have to all go find the number on page 12 of the PDF and make our own spreadsheets. So I want to encourage folks to go use a free open source tool to do that for themselves, so we can do this faster together.
Yeah.
Stacy, can you mention the product categories that'll be in there?
Concrete, steel, timber, glazing, aluminum, insulation, gypsum board, carpet, and ceiling tiles.
That's great. That's excellent. That's a great amount of materials that can be evaluated. Also, there's the third-party verified documents that people can look at, like the GreenCircle certification, and also we saw Declare. So just definitely keep it in mind. There's a lot of sources of this information, but it seems like if you're really wanting to dive deep on this, the EC3 tool would be an excellent tool to use. I am going to sign off. I say we should sign off here. A lot of people are dropping off. We are past our time, and we will actually respond to these questions. But I do want to thank everybody for joining. I really want to thank Lisa, Kirsten, and Stacy for presenting today. And any questions going forward, just feel free to shoot out an email. But we will be sending the recording. We'll be sending a PDF of the slides. And we're also going to work on responding to some of the questions we didn't get to answer and send those out as well. So thank you, everybody. Really appreciate you joining, and look forward to seeing maybe many of you at Greenbuild. I know we'll all be there, so I look forward to catching up there. Thank you again.